myself. So hello everybody, welcome to LondonR Online. I'm Laura Swales. I am Mango's Community and Events Manager. And yeah, I organise all of our LondonR events and also, excuse me, the R conference too. I just ate some crisps before we started because I was really snacky. So yeah, welcome. Who are Mango? We were formed in 2002. We were recently acquired by a company called Ascent in 2020. So this has really expanded our capability. Before, our main focus was data science, and now with Ascent, they have kind of software knowledge and skills. So together we can do a lot more things. We're based in Chippenham, Bristol, and London. We're all just starting to go back into the office, which has been a really nice change of scenery from my dining room. And yeah, we organise a range of data science events, and I'll go on to say a little bit more about that in a minute. As the same as everybody in the world, we are hiring. So check out our website for more information on the jobs that we have currently. And EARL. So EARL is a conference that we organise here at Mango. EARL stands for Enterprise Applications of the R language. Usually we're based in London. There's about 300 people that come along. We have about 64 speakers, and it's a really, really fun event. Obviously, we've had to take it online last year. And again, this year just felt like the safest and most sensible thing to do. But it does mean that we can open up the event to a lot more people. We're not restricted by location. And because we have less overheads, we can charge a lot less for tickets. So that's really exciting that we can make it even more accessible. And we're pleased to say that we're going to donate the profits from EARL this year to a charity called DataKinds UK. And they specialise in helping social change organisations or charities use data science. So hopefully we're going to do some projects with them kind of leading up to the event as well. In terms of what we're doing at EARL, we're doing it over a week. Monday to Thursday, we've got workshops. We're doing Intro to Shiny, package development in R, functional programming with Per, and web scraping and text mining lyrics in R. They are all afternoon workshops, 2 to 5 p.m. UK time. Just thought, afternoon might be easier for people in America to join us as well. And then the Friday, the week will end with a day full of presentations. So this will be 30-minute presentations from people that use R every day at work. And we've got one of our keynotes announced already. And we're really pleased to have Jacqueline Nollis, who is from Saturn Cloud, and she's presented at loads of really cool data science events. Some of you might have seen her at RStudio Conf this year as well. So yeah, tickets are on sale. Check out allconf.com. I am updating the redirect on that URL, so it'll go straight to the ticket page, but all the information is there. The workshops are £90 for half a day, and the Friday presentation day is £9.99. And then yeah, LondonR Online. If you would like to present, please drop me an email at events@mango-solutions.com if you'd like to present. Like I said, and I've just run a poll just to kind of gauge people's interest in coming back to in person. But yeah, let me know if you'd like to present. I think I'm going to be doing it online probably up until EARL, and then I think after September I'll look at going back into London if there's interest, or maybe if enough people want to come, I can do something in the summer holidays. So it really depends on people's interest if they'd like to come back again. So tonight we have a really great agenda. So first up, we've got Robert Hickman, who'll be presenting on amateur professional football analytics using R. Then we have Gary Hutson from the NHS presenting on NHSDataDictionary, the joys and perils of R package development. And then finally, we have Alejandro Rico from Mango, who's a fellow Mango Solutions person. And I've never actually met Alejandro, just online. And he will be presenting on encrypting with R, from protecting passwords to setting up a blockchain. So just a couple of bits of housekeeping. So as you all have seen, we have moved to a different piece of software. We used to use Zoom, and we're now using Big Marker. This is my first event using Big Marker, so please forgive me if anything weird happens, but I would really, really appreciate any feedback anyone has. I won't be offended at all. We moved to Big Marker just because it mainly made the kind of process for you guys easier. You know, getting a ticket, you didn't have to create an Outlook reminder on your calendar. It was all kind of just one thing that did the whole process. But yeah, any feedback you have on your experience as an attendee would be really, really appreciated. So you can either, I'm not sure if you can drop me a private message on here or just pop it in the chat at some point. This is being recorded. I will put the recording up on YouTube probably tomorrow. And also there is a slight delay from me talking to you hearing. I think it's about 10 seconds. So at some point, the presenters will finish and ask for questions. And, you know, I don't want the presenters to panic that there's this really awkward pause between people asking questions. If you have questions, just type them as you go. Hopefully you can all see that there's a Q&A section on the right-hand screen where there's chat and Q&A and poll. If you pop your questions just as you go during the presentation, I will read those out to the presenter once they've finished presenting. And in the chat, you can just, you know, put whatever you want in there if you're enjoying it. Anything else for me to tell you? If you enjoyed tonight, please tweet about it. We're at Mango the Cat, hashtag LondonR. And I think that is everything from me. So what I will do is stop sharing my slides, just put my camera on, and I'm going to hand over to Robert. I'm just going to bring you on stage, Robert. Okay. Cool. Right, you are on stage, Robert, so if you'd like to share your mic.
Yep, is that working?
Cool, I can hear you.
Is everything, yep, if I start sharing my screen, is that?
Perfect, yeah. I'll turn off my camera.
Window, that should do. Hopefully that is now coming up soon. I should go into full screen. Let's try that again. Yeah, is that nicely on?
Yeah, it's just coming on for me. Cool. Yeah, I can see your slides. Awesome. I'm going to mute myself now.
Okie dokie.
Over to you.
Perfect. So yeah, this is a talk that when the call went out, me and a guy I used to work with at a League One football club through the town, thought we of giving. Unfortunately, the timing didn't work out perfectly, that he's just moved to the United States for a job. And also we realized quite a lot of what we actually wanted to talk about, it was going to be difficult without sort of breaking agreements. But so what I'm instead going to do is to basically give an overview, a top-down overview of like sort of football analytics, the kind of community, and generally sort of try and give the talk I kind of wish I had seen, 4 or 5 years ago when I started getting going with this kind of thing. And hopefully it'll be useful to people. Hopefully people have questions, and yeah, hopefully it should be fun. But yeah, so the main things I'm going to talk about are basically what we talk about when we talk about football analytics. I feel like it's like many sort of data science terms, it's fairly nebulous and doesn't really mean anything. So people can kind of get lost either in the weeds or not even approach it. But just break it down, like make it very simple, show a lot of like public work that's out there, hopefully try and give people some inspiration. And then talk very briefly about sort of what R in particular I feel like is good for in football analytics, like why I think it's a very powerful language, why I think more people should be using it for this kind of stuff. And obviously, like, this is a LondonR thing, why I think it's also good for people to be doing this kind of work in a lot of this stuff is in people's free time, but why I think it's very beneficial to sort of look at football data, munge, scrape, plot football data, and why how it sharpens sort of skills in R. And then finally sort of finish with like a dump of resources, so that if people do have any inspiration, then they can go off and, to their heart's content, make some nice stuff. So talking about like what football analytics is, I kind of wanted to start with like example from this weekend. I don't know if you can hear the sound or not, it doesn't really matter. But watching football with my dad, where the cross comes in and the player misses the shot. Oh. And just, in the pub, hearing people be like, he should score from there, or like 9 times out of 10, he'd put that in. And this is really what football analytics is at its core. It's just like taking sort of, statements that everyone makes when they watch football and trying to, maybe test them against data or put numbers to it, or, just go from like the narrative to like some sort of hard, analysis, and combine it to data. But really with like, there is a sort of overarching goal as well that, which I won't really go into here, but in the idea being that if we can instead train computers to like watch, these matches in greater details than a single human at the pub does, then you can start to sort of extract information about the game and like what players are actually like good at football, and what are like winning strategies. So my sort of training is in neuroscience, so I have a deep love affair of like 3 levels analysis things. But basically, I'm going to sort of try and separate out the examples I give into analyzing teams, players, and events. Where teams are, as it says, the teams are looking at like whole team effects, single player effects, and then events. Even by a sort of a single event on a football pitch would be, for instance, a single pass or a substitution or a foul, for instance. But really, all of these kind of like build up to each other and are pretty much like overlapping, and it's all, it all interacts with itself. But starting with, people analyzing teams, so all this stuff is going to be like public-facing work that I've sort of just scraped off Twitter in the last like few weeks. But there's various levels for all this stuff. So, for instance, some plots of like team age against minutes played. We're looking at sort of players' peaks and just really trying to like nicely visualize, squad depth in a way that is very easy to look at in like 10 seconds and sort of grok the major information. Also, plotting teams in terms of, shots taken versus shots per goal in this example, but to sort of get an example of like how good teams are. But even going beyond sort of like descriptive statistics, onto modeling teams and modeling like sort of the league position against predicted league position based on results and events and matches teams have taken part in. And finally, like a lot of stuff on sort of tactical breakdowns of teams is also in the public domain, but very like used within like football teams themselves. So for instance, in this one, using k-means on pass clusters to find overrepresenting pass clusters from MLS teams here, which is like a great, it's all stuff that isn't like super complicated, but is actually like quite a big boon to teams for people who can do it. And it's like, it's not as widely used as like it should be, based on like how people can do this and like get the data and make this in a few hours if you know how to use R. And the same thing is sort of true for analyzing players. And so this is like from The Athletic, a newspaper that does a lot of data work, just trying to find nice ways to like represent sort of complex data about the game. And so, for instance, a single player's ability at various skills, or the number of shots players take to score, to try and find out sort of how efficient players are. And one thing also I really want to like focus on in this talk, especially I think these examples make clear, is like for a sort of sub-community of people online doing this work, I mean, and these are professional examples, but the standard of like sort of data visualization is extremely high. And I think actually a kind of unique thing to like the subculture where it's really trying to like push forward what's possible with, simple data visualization. So even looking at, single players where people take shots from. And again, all this is like public facing work, super high quality. And then finally, onto events, which I think is sort of like, the holy grail of football at the moment, where looking at, N,000 shots taken over many games and trying to predict the probability that any shot would result in a goal. And this sort of gets more away from the descriptive side and towards where you can actually get into really like quite hardcore modeling with football data. So this is using, actually there's a nice range of models used in the post I stole this from, but sort of general linearized models all the way up to, XGBoost and then neural networks. And then even, people pushing into deep learning from public data by using so freeze frames on shots here, where you have defenders and strikers and goalkeepers, and sort of converting this into positions and running it on a CNN model to predict the chance that this shot from this location will be scored, and then comparing it to actual goal outcomes here. So hopefully, this is extremely like a whistle stop, but hopefully like at least gives people like an overview of what people are doing when we mean football analytics at the moment. And also just generally that So all of this stuff is sort of built from events, as I said. So like, for instance, a single shot here, but then towards like what is going to be sort of in the next few years, and it's sort of starting as a revolution now, in that this doesn't take into account, the whole pitch. It only takes into account, maybe a single pass. There's like 10 players here, where data providers are starting to like release some example tracking data, and also like professional clubs are starting to really use tracking data to see the location of everyone on the pitch at any point, and then try and model, what is the best thing that any player could do at any point, and which players are doing those things, which players are like making efficient chances. So this is a simple pitch control model using players' velocity to work out which areas of the pitch they, quote unquote, control, which areas of the pitch they can get to very quickly. And then even beyond this, like, so how I got started in football analytics was just sort of like data anarchism, where the Guardian, for instance, runs a football trivia column, and these are two questions I answered on a blog I run, where, for instance, trying to find the football team that had the longest sort of geographic cup run. So this is, for instance, Newcastle United in 1923, who had to travel, up and down the length of the country in about 4 or 5 games. And then also which Premier League players played for the national teams with the lowest, like the least good national teams, basically, in which I took to mean like lowest ELO rating, or a simple model. Where, this is like, this is not really useful to professional football clubs, but it's extremely useful to get a domain knowledge on sort of analyzing football. And I think it's fun and low stakes, but also it's a really good way to just get a nice range of sort of data manipulation and visualization skills that I don't think is really present in a lot of other, hobbyist analytics. For instance, this is like combining geography scraped off Wikipedia with, football results from the last 100 years, and there's some non-trivial trying to like, lags and leads to try and work out which teams are sort of progressing the FA Cup. So, I mean, hopefully, which leads me on to sort of like what R can do for football analytics. And I think the main thing that R really is suited for, and also like other higher level languages, but especially R, is that there's a lot of sort of very gnarly and heterogeneous munging. This is not, like perfectly clean financial data or something. There's a whole, even to get very simple stuff, there's a whole load of trying to filter and select and, combine data sets. And a lot of these data sets require quite intense cleaning. You can get very high quality event data sets, but to sort of match up to exactly what you want to use it for can require some pretty difficult sort of group bys and summaries, which is why R really excels at with the whole tidyverse. Also a wide range of modeling approaches which you can use, which I sort of hopefully touched on a tiny bit in the previous section, but it's something that, obviously there are other program languages that can do this, but R has like such a great sort of statistical bedrock that generally if there's a modeling approach published somewhere, you can find packages which allow you to do those statistical tests or build those models and run them. But especially I think two things that R does have that other languages I think don't to the same level are the targets pipeline from Will Landau and sort of the previous like make like pipelines, which a lot of this data is it's football data, so it's coming in almost weekly. If you look at sort of results for a football team that you're running the same analysis on, but on a new match, and just being able to like drag and drop your new data in and get the pipeline to scope that and rerun is a huge benefit. And also saying that like I probably should put in like extra bold is the ggplot2 visualization is such a it's so powerful, and such a lot of the work is sort of, well, both getting your foot in the door by making eye-catching visualizations, but then also getting football clubs to listen to your work, which generally is going to be just how well you can actually get those ideas down on a graph or on a plot. And so being able to like have the freedom to do that with ggplots, like infinitely many geoms and like theme elements and stuff, is just like such a powerful boon for football analysts. And also just to sort of like finish off, and I'm a bit early, but hopefully there'll be a lot of time for questions as to what football analytics can do for like someone's like, why should you dedicate time to trying to do this other than just that it's fun. I think there's a few reasons. The main one is that probably common to a lot of people who've used R. There's a very nice like open community with a wide level of sort of experience and niches. I put semi here because there's sort of a over time there's like a growing and fallowing of the open field as people sort of put work out and then get hired, which is quite interesting to see. But in general, there's so many people doing this across the world, and it's built into a really nice community online that people sort of feedback and inspire each other. There's also, again, not unique, but a very useful to have, a lot of conferences and competitions which will let you sort of give in a research proposal and then supply you with data and the ability to present your work to wider audiences. So for instance, some of these StatsBomb and Opta are data providers which give data for good proposals and allow you to present, and then sort of individual teams are also starting to do this. So Leicester City have a small analytics conference now, and some of the US teams as well are starting to do this. And also because it is a field where, even though a lot of people get started in for fun, there are quite a few professional jobs out there for people who, really want to take this, into their professional life. So obviously for working as an analyst at a sports team and, scoping out opposition or scouting players, but also at data providers, a lot of sort of data analysts and also data engineering roles. Even in the media now, it's starting to become a bigger thing. So I mentioned the Athletic and also the Analyst I showed plots from, which is the sort of a spin-off of Opta as a newsletter. And finally, also in terms of sports betting, there's a large, quantitative community of jobs. But then also in terms of even before going that far, for people who are sort of just getting started with R, there's quite a lot of open quote unquote medium data, but it's not large data, but it's not, these aren't small MT cars data sets. So you can actually do quite a lot with them. So for instance, StatsBomb, who I mentioned in the last slide, have 2 seasons worth of Women's Super League event data. So this is, every pass in a whole league's season's worth. And then that, which opens you up to do really professional grade modeling analysis on. Also, I showed some sort of quick tracking data. One of the companies that provides this, Metrica, have released, I think, 2, and they're going to release a 3rd soon, match worth of tracking data, which again, it just lets you, it's not enough to do maybe the highest quality. You can't train a neural network on this or something, but you can at least get going with it, get munging that data and start to implement models and see how they fare. There's a great package from James Curley, the Ink Soccer Data package, which has, I think, about 20 different countries worth of league results from the last N years. I think for the English data, it goes back the whole 100 years, but it's been a while since I used it. And also, just online sort of football data aggregators, so Football Reference and Understat, which, is also just a great way to practice, scraping skills to get high quality data off of, and then even disparate data sets like Transfermarkt on Wikipedia. And I think getting using these data individually is great, but actually when you try and synthesize this data together and you're taking dirty data off Wikipedia, cleaning it up, trying to match it up to professional level event data, there's a lot to learn in terms of how to take data all the way through a pipeline. And finally, to finish off a bit early, I just put in a load of resources because I said there's a great community around this. So there's 2 nice sort of R libraries here for plotting football data, Soccermatics for making, I think, actually clones of some of the plots I showed earlier, and then GG Soccer, which is allows plotting a nice sort of football field background to make plots look a bit more interesting than just dots on a screen. The English soccer data package I mentioned in the last slide, and also World Football R, which is sort of it's not really an API for some of these websites that have football data, but has sort of scraping tools that make it a lot easier. And also the StatsBomb R package, which gives an API to that free event level data I mentioned just before. There's also a great post from StatsBomb doing more with StatsBomb data in R, which sort of, for anyone who's just getting started, basically takes through the first sort of 2 hours of using that data and making nice things and really getting people up to speed and getting over that initial hurdle of using the data. And then finally, I put like one YouTube channel here, which is the Friends of Tracking, which is kind of like an initiative that's starting coronavirus and is sort of like professional analysts sort of in conversation about their job or different types of modeling or data providers. And I think is a really just a great resource to have. And then finally, just to finish, like one of the reasons why I think also, as I kind of touched on, it's a really good sort of subfield or sub-community to get involved in, is this idea of, this is from like the 90s, of the scene that celebrates itself, where, one of the great things about R, and I think a real advantage R has over other programming language, is the great online community and, its ability to celebrate each other without, without getting egos in the way. And I think to a greater or less extent, the same is true of the online football community. It's a lot of people who are like, feel very lucky and, happy to be doing what they're doing. And so there's a lot of, I think there's a lot of sort of great synthesis that happens online, which, is not true of every sort of field of like hobbyist analytics you can find, and it just really makes it a lot easier to sort of get going and keep going. So yeah, so that's all from me. But I mean, as I said, this is a very whistle-stop talk, and I hope there's some questions, and yeah, feel free to ask.
There are some questions.
Cool. Shall I stop sharing, or is?
Yeah, you can do. Do you want to put your camera on, because your camera isn't on actually?
Sorry, I didn't know that.
That's okay.
Is that should be on now?
There we go.
See my weird headset.
That's fine. Thank you so much. We do have some questions. If you do have any questions, can you please just pop them? Hopefully you can see there's a Q&A section next to it where it says chat. I appreciate there's going to be a slight delay from when I say this. But yeah, if you could just pop them there, that might just make it a little bit easier for me to keep track of them. So Ryan Hill asks, why does football have such poor data compared to something like basketball, where every play is recorded with great detail?
Yeah, I mean, I think so. Opinions may vary on this, but my take is that it kind of comes down to sort of almost like geographical factors in a sense. Oh, my computer's asking me to restart.
Perfect.
I think like that's okay. Hopefully that shouldn't quit. But
don't leave me to answer this.
Yeah, there was a lot of push in like American sports around sort of the turn of the century to sort of really get analytics going, and I think it's been a bit slower to pick up in football just because literally just because it's not as big a sport in the US. And I think even like a lot of the better football analytics still is done in the MLS, which you might not imagine based on the amount of money that sort of goes around in the European leagues. It is getting like quite a lot better very quickly though. So the event level data is pretty good, and the companies, it's almost like as soon as you get used to one sort of set of event data, it's out of date. So StatsBomb have like revolutionized their event data within the last, I think, 2 months. And also, as I mentioned, like this tracking data is slowly coming in. It's also a little bit harder to track football data just because of the size of the pitch, so the height you need to record from to track players well. But it's a good question. But I think football is catching up. I think generally people say a lot of football actually comes from ice hockey, and it's generally like 3-4 years behind. But yeah, hopefully not for too much longer.
John Dunn asks, do you know how some of the underlying data is collected, like all passes made in the WSL? That's an incredible amount of data. What programs are used for collecting the underlying data? Yeah,
so it's huge. I'm going to get the numbers off by maybe an order of magnitude here, but I mean, I think it's 2,000 or 20,000 events per match, probably 20,000, because you can imagine it's multiple per second for an hour and a half. So the way this is traditionally collected is literally people watching the matches with sort of specialized software and, point and click, tracking stuff as it happens, which sounds like, I mean, I've never actually seen someone do it, and it sounds impossible, but apparently you can just get very, very quick at doing this by training. There's also like a huge push to sort of automate this with computer vision. So there's a lot of jobs in sort of like, these sort of data collection companies for computer vision engineers to try and extract this data automatically from, from specialized cameras, but also like ideally from just broadcast feeds. So if you have a match on TV, you can just feed it through and take all the the data out from there. I think hopefully that answers a little bit towards that.
Okay. Andrew asks, he's not familiar with targets package. Can you say a bit more about how you use this?
Yeah, I mean, I can't say enough good things about the targets package. So this is built out of a few packages that were like floating around for the last few years by Will Landau, who I'm going to get wrong. I think is at Roche, but it's maybe another pharmaceutical company. But basically allows you to build targets pipelines which sort of act in like a make-like manner, so that it can scope when stuff has changed. So if for instance you have a simple pipeline of load data, run a model, make a graph, if the data in your my data documents folder changes, it automatically scopes that and runs just everything upstream of it automatically, so that you don't have to pay so much attention to going into your markdown notebook or something and running each chunk again. It's really really useful. I think useful just generally for any sort of analysis, but especially for this kind of thing where you're having to rerun the same pipelines over and over again as more data comes in.
Okay. I'll make this the last question. I think they're both kind of a similar thing. Are you aware of any Moneyball moments for soccer analytics or football? Has professional football analytics grown slowly, organically, or were there some teams that had massive success, scouting tactics, etc., and others are racing to catch up?
So I'll start with the first sentence, just because it's quite timely, actually, where in the second league, the championship, the playoffs for the last two teams to be promoted, one of them, Barnsley, I think, has Billy Bean, who is the original guy coming through as a Moneyball at the Oakland Athletics, I want to say. He's a minority stakeholder, I think. So there's been a lot of articles written in the last week about sort of Barnsley and Moneyball football. But no, generally most teams, I reckon, most of the sort of the top 50 teams in England would have at least some analytics department, and most teams even below that will have some form of a data analyst. It does vary by team. Liverpool in particular have been sort of widely praised over the last few years for having a very involved sort of a data analyst team, and then another whole modeling and sports science team on top. There's a lot of interesting pieces that have been published about that. So I think it is happening, and I think the point that sort of people tend to make is just it's so cheap compared to the huge amounts of money that's sort of swimming around in sports to hire very good people and invest in the data and the computing. I think it's inevitable that eventually the teams who want to do well and be run well as a cost-effective business are going to be doing this kind of thing.
Okay. Actually, I think we've just got one more minute for Andrew's question. Andrew says, one of our former sports science PhD students was collecting data using GPS trackers in training rather than in live games. Have you ever come across that sort of data gathering?
I think we looked into this at the club. We were sort of looking into maybe going into tracking data for a little bit, and it's a lot easier basically to sort of just gather this data and record the thing. But I've never actually seen it used. I've never heard someone talk about them using it, so I don't really know how effective it is. But I imagine it's a very cost-effective way to do it.
Okay, cool. All right, thank you so much, Robert. That was brilliant. I've got loads of really great questions there.
Thank you.
No worries. Thanks for joining us. Okay, I am going to take you off stage, and now I am going to bring on Gary Hutson. Cool. I've just brought you on stage, Gary. So if you could share your microphone and your video. Perfect. There we go. Cool. I didn't realise that you were based in Nottingham, Gary.
Yes, been based in Nottingham for a while. I used to travel to London every day when we started first speaking, Laura. So can you see the screen?
Yep, all good. Right, I will be quiet and let you carry on.
Okay, thanks, Laura. Okay, today I'm going to talk to you about one of the packages that I've got onto CRAN called the NHSDataDictionaRy. Perhaps some of the joys and perils of going through that development process. And I'll give you a short demo of what the actual package does. Okay. If I can iterate my slide, that'll help. There we go. So a little bit about me. Obviously can't work with PowerPoint. I'm a public sector data scientist, statistician, deep in machine learner, interested in all things R and Python. I've been in the criminal justice service for quite a long time, and then I most recently been working in the healthcare service. Been coding in R for about 8 years, and I also work in Python as well. I'm a co-chair of the NHSR community, which was established to get our kind of business intelligence analysts and researchers using R more frequently in the NHS, still driving that agenda forward. Prior to that, I also worked as head of data science at a company called Draper and Dash, and I was also the senior data scientist there. So we aided in creating predictive modeling projects around healthcare and created something called the Data Science Platform. Have a look at the Draper and Dash website and check that out. I'm currently working back in the NHS for a commissioning support unit, something called Arden and Gem. Okay, so how the package arose. So the NHSR community give out package funding grants to NHS and social care organisations. So essentially we had this idea of this data dictionary package, which would be a web scraping tool to web scrape basically lots of different lookups. So in the NHS, there's thousands and thousands of lookups for different types of conditions, something called where a clinician kind of works in terms of their treatment specialty. So we thought it'd be a good idea to have some kind of way to mine this down into R. So I started creating the NHS Data Dictionary for that specific purpose. But it was made possible by the fact that we were given this package funding. So we're given grants in terms of development days. Otherwise, I wouldn't have had time in my spare time to develop it. So in terms of the NHS Data Dictionary then, before I get into a bit of a demo around it. So the key benefits of this are in trust. There's 223 trusts in this country, in the UK. And they all have got their own version of these NHS Data Dictionary lookups. So I thought, actually, why don't we rationalize this and come up with a way whereby we can just centralize it all in R? So it's always up to date. It's a web scraping engine that brings back the NHS Data Dictionary lookups in real time. It allows for rationalization of NHS lookups, and it provides consistency to those lookups as well. It gives you the ability to form custom scraping of websites and website elements, simple wrappers for more complex packages like HTTR and XML2 and things like that. And it's open sourced and maintained by the NHSR community centrally. So any package maintenance or developments that need to be made can be done there. So in terms of the package itself, how you use it, how you install it, I'll just launch into a live demo now. So if you can see my screen, the package can be installed as any package can be installed off the CRAN website. So to load the package in, we're going to use these libraries. So initially, one of the elements, this is more NHS specific, but it allows you to do it on other websites as well, is to scrape all the NHS data elements. So we've got 2,601 lookups that it's going to bring back. So if I analyze that in a tibble, it gives me the actual link, so what the lookup relates to in terms of healthcare. And believe me, this kind of really shortens the process instead of going looking for NHS data repositories and trying to find the thing that you need. It also allows, like you say, more smaller healthcare providers like perhaps GPs and stuff like that to use these lookups as well. Might not have the infrastructures like what we call secondary care providers. So it gives you the URL and the full URL, and that gives you the XPath to the relevant lookups that you need to access. So that's how we extract the data links into a nice data tibble. What we're going to do now is actually use some other functionality in the NHS Data Dictionary. So the link scraper will essentially look on any website URL that you pass in, and it'll return all the active anchor tags on that website. So essentially, if I run that, for some reason it's blocked it today. Okay, so there's obviously a problem with the SSL certificate. This is not going to go well. Okay, let me just restart R for a second. Apologies for this. Okay. Let me just load that back in. I think there's an issue with the website. Okay, it's still not liking that website. Right, guys. Okay, I think I've got a problem with my internet connection. This is not really going to help when I'm trying to do a live demo of the tool itself. What I'll probably do actually is I did have a contingency to this just in case I had issues. So what I'll do, just hold on a second, is I'll bring up something that I prepared earlier. Okay, let me talk you through this then. So I've actually knitted the Markdown document. So to access the data links, this is what we just showed you. It brings back this tibble, so that was working fine. So then I'm going to use a different website, and what I'm going to do is scrape all the links off this website. So I'm going to use the link scraper function to pass that URL in, essentially. And then what it will do is it will give me back everything that's available on that website. So what the link name is, what the URL is as a tibble. And obviously they've got some weird formatting on this site as well in terms of anchor tags. But it's going to bring back everything that's actually available on that specific page. And then you can use things like slice to slice the subset of the results, which will bring back the actual blog name pertaining to that particular web scraping task. Once we've kind of got this subset of a result, so I want to view all the blogs on the R community website, I'm going to browse URL in the utils package, which will essentially open a browser from R to your actual default browser. So it's going to open Chrome up, and it's going to open it directly on the page that you need. So it's going to open it directly on there. So the actual power of this, so where it actually works the best, is actually scraping HTML tables from the website. So to do that, I'm going to filter the NHS tibble that I created earlier. So the list of lookups and data elements. And what I'm going to do then is I'm going to run the TableR function, which will bring back HTML tables. So it's named TableR. It's got an equivalent. If you want to bring back website text, there's a texter as well. So it'll bring back HTML tables with a specific XPath. So all the XPaths are pre-calculated off the back of that website. And then essentially what you can do is pass in the full URL from that tibble. So from that activity treatment function code in NHS speak, essentially where the consultant or clinician works. So general surgery, urology, breast surgery, etc. We're going to pass in the XPath to get back the national codes table. So that's already available in the reduced tibble there. And then we're going to give it a unique title, so what the actual dictionary type is. And this can be, we could then iterate over all these lookups and create essentially a master list of lookups if we needed to. So the next stage is so assume you've got some NHS data. You don't have access to a data dictionary database like some bigger trusts do. You want to then be able to use your data to perform lookups against that data, against the NHS Data Dictionary kind of repository. So I'm going to generate some spurious NHS data. I'm going to pass in the specialty code. I'm going to pass in a couple of specialty codes that I know it will return. I'm going to do some just sampling from a random normal distribution as my activity counts, and I'm going to repeat May. So I'm going to rep May 5 times because I know there's five values in that vector. Then I'm going to left join onto my national codes by the specialty code that I've created and the code that's been returned. And you can see now we've got the descriptions that have been returned and what dictionary that belongs to. So this really is beneficial when you've got lots of different lookups you need to perform. And as you can see, it provides you 2,000 odd lookups that you can utilize. The next iteration of the package does those intermediate steps all in one go. So essentially, you just pass in the parameter that you need to filter by, and it'll bring you back the relevant activity treatment function codes that you need, or whatever type of lookup that you require. So essentially, you just pass it in as a string, and it'll accept any different type of string, as long as it matches the dictionary type that you're looking for. So that's essentially a way to shorten that process down, because we had intermediate steps before. Now this will be one consolidated function. The next stage is to use the XPath text. So if I want to go onto a website, so say I want to utilize this website, and I'm going to bring up my web browser in a second. That's the NHS Data Dictionary, and this is essentially the data elements that it's utilizing and scraping. So to get other components, so to copy the XPath here, I can inspect it. My HTML element. I'll just find the table class there. So if I wanted to get that div class there, I can copy my full XPath. Essentially, this is all done for you. But if I want to copy other elements on the page, like the description, I can copy that. And then essentially that's going to return text. So we'd then work with the XPath texter to return that data. So I'm going to just go back to my Markdown document. So the texter function allows you to scrape any text off any website, essentially, as long as you know the XPath and the URL. It will then return a list of results. So this is my result that you're looking for, this abbreviated mental test score. And it will give you new lines. So we have to do a bit of text cleaning post that. It'll show you the website that's been passed, what XPath was passed to it, the HTML node result, date, time it was accessed, and who's actually accessed it. And then you can do some custom text cleaning on it, so removing new lines and breaks, trim any white spaces, convert it to character, etc. And then that's the clean string.
Can I just, sorry, Gary, just to butt in a second. Amit said, could you make are you able to zoom in slightly on the web page?
Sure.
If possible, thank you.
Is that better? Is that better, Laura?
Yeah, that looks better. Thank you.
Cool.
Thanks, Gary.
Apologies. Yeah, so then you can clean the text, post that. So essentially it gives you the capacity to bring back all active kind of hyperlinks on a web page, to scrape HTML tables, to scrape individual bits of text, and it provides lots of lookups that you can utilize with NHS data. And then it provides a couple of other Excel-friendly string cleaning functions that you might be used to Excel, instead of, essentially, if you're coming at it from a business user in the NHS. Most of them have used Excel, not a lot of them have used SQL. So we're trying to introduce people to start using this package or in the whole. So it's kind of a way to get people to start utilizing R more readily. So we've got like left Excel, right Excel, which will perform a lot of text cleaning and extracting that text that we cleaned earlier. So right clean, mid Excel, length of Excel, etc. It also includes something called open safely data. So this is, some guys might have heard of an author called Ben Goldacre. He works predominantly in the NHS, and we've been kind of working with him to build up this open safely repository. And essentially the NHS Data Dictionary on CRAN allows you to also scrape data from the open safely website as well. So essentially what it does and what it provides is a lot of custom web scraping and NHS lookups. So when I first attempted to create this package, it was like going on a perilous journey, because I was thought, what do I need to know before I kind of embark on this perilous journey, which is what this image is. So I learned quite quickly that DevTools was my friend when I came to develop the package and getting it CRAN ready, so to speak. So my favorite commands that I used a lot were devtools check. So make sure that cran's equal to true. So it does the additional checks that are needed. DevTools document. So if you've got all your kind of R scripts laid out with Roxygen skeletons, it just documents them for you essentially and creates all the manual and lookup files that are needed in the package. If you're like me, you're a really bad speller, check spelling in your R packages so it looks professional. Always helps. And then once all those checks have passed and you've fixed all the warnings and errors and notes that CRAN needs you to do, then you can then go on to release a package using DevTools release. So DevTools release essentially goes through a whole set of steps to allow you to make sure you've carried out all the necessary checks. So have you tested it on different versions, different operating systems, different compilers? It allows you to all do that. Are you the registered maintainer and all those kind of things? So it gets it all ready for then submitting to CRAN. Again, the Roxygen skeleton's your friend, so make sure you read about Roxygen skeletons and make sure you include it in your R scripts. And don't be scared of the Roxygen skeleton, because essentially without that, it's a lot of manual documentation. And it also allows you to then integrate it with things like page down and continuous integration, Travis, GitHub Actions. So essentially every time you make a change, your package is always up to date and it's got the most recent and relevant documentation. So if you don't know anything about R packages, that's the book to go to. It's a bit like the R Package Bible by Hadley Wickham. And obviously he knows what he's talking about. I saw him talk at the R conference and he's got a hex sticker of the package right on the back of his wall. In terms of then coming to submit the package to CRAN, they've got quite high standards for what they expect. So my big tip here would be patient. Don't get despondent if you have to resubmit your package. I think more than once. I think I'm down to about 10 times before it got accepted. So it feels a little bit like Gandalf saying you shall not pass, but just keep on being persistent and you'll get there in the end. So the joys then. The joys are when you receive this email. So if it's built on Windows, you'll get an email from UE. It will say that your package has now been built for Windows and it's going to be published within the next 24 hours into the corresponding CRAN directory. So, I mean, that's just sublime when you see that message come through to your maintainer email. It's fantastic. Joys part 2. So then you do a search for your package or you get your first Stack Overflow comment about how to utilize the package, which is how one of the authors got added to this package. Essentially said, here's a whole load of functions that will make it better. And I said, do you want to be a package maintainer? We had this conversation on Stack Overflow. And essentially then he enriched the package even further. But as you're seeing it online, seeing it, all nicely compiled, it's great. And then clicking on your vignette and seeing that actually your vignette's built and it looks relatively nice is all good as well. So in terms of R packages, if you work for health and social care and you're watching this, we're working with a company called HexyTime. Essentially we volunteer our time as mentors in the package development process. And the team at the NHSR community will help and support you in essentially taking your idea, getting some package funding potentially, and then seeing it through to you actually either publishing it on GitHub or putting it onto CRAN. So yeah, that's something that we're developing at the moment with a company called HexyTime. So we're registered on there. If anyone's interested, get yourself registered and you can reach out to us to perhaps approach us around package funding. Again, I've finished a lot quicker than I thought, Laura.
That's fine.
Apart from the technical glitch from my internet earlier.
It's always the way. The one time that you need something to reliably work is the time that it's going to crash, do a restart. It's classic. But you handled it very smoothly.
Oh no, I got a bit panicked.
I couldn't tell at all. Yeah, if anyone has any questions, please feel free to pop them in the Q&A section. I know that they might take a couple of seconds for any questions to come through. Maybe you could, while I'm just waiting for some questions to come through, tell us a little bit more about the NHSR community.
Yeah, sure. So the NHSR community is a community that's been funded to upskill essentially analysts in the NHS. So they provide free training, obviously funding for solutions that are proposed. There's a technical advisory group that we sit on to review any funding and any solutions that need to be built. And essentially, yeah, it's been a way. It was established in 2018, and it's been kind of growing year on year in terms of its membership. So we started with around about perhaps 20 interested people, and it's grown to over, I think, on the last conference that we held. So we have an annual conference as well, the NHSR Community Conference, which also, looks for abstracts for speakers, similar to the Earl Conference. It's grown from around about 20 going on to 1,000 plus people now, and it's kind of one of the regular things that people quote when they're talking about R and usage in the NHS. So it's really been a success.
That's amazing. Okay, so we've got some questions. Daniel asked, how long did it take to make the package? What was the biggest challenge?
So the biggest challenge, so I'll approach the first one first. So it was around about, so I had a lot of the code and ideas initially from lots of work that I'd worked on prior. But it took around about 2 to 3 months to develop, to get all the functions and the proof of concept in and do all the documentation, which is the bit that I kind of hate. So Roxygen is great for that because it kind of automates that function. So around about 3 months. In terms of the actual whole process and getting the funding and the time really is, if you're not interested in developing a package in your own time and you've got a really full-time heavy job, then perhaps look at these kind of mentorship schemes or approach areas that might give you funding. So with health and social care, we do fund that. And in other areas, it's just kind of ambition and seeing it through. Does that answer the question? Have I missed any parts of that, Laura?
I think that's answered everything. We've got another question from Ryan. What's your advice around getting people involved in adding to a package? I built and maintain an internal package, but haven't been able to get anyone else involved so far.
Okay, so I always try my packages initially on GitHub to see if they're actually going to be useful or not. So that's one way to get people kind of onboarded, and also do a bit of marketing internally as well. So, register for our bloggers and kind of put a call to arms to say, does anyone else want to be involved in enriching this package? So actually GitHub initially is a good starting point, but then actually through perhaps making people more aware, use of social media, people have started to come forward to make recommendations. The reason this got on Stack Overflow is there was an issue whereby it was not converting name list right. So one of the kind of guys said, I'd like to contribute. What do I need to do? Here's a set of functions. We got talking. And then obviously the next iteration of the package was built. And that then made the person who actually collaborated, made it onto the package list. So also be open about welcoming collaborators, because some kind of package funders are a bit closed off to that kind of thing. So be welcome. If there's a good suggestion on Stack Overflow or via email, just run with it.
Amit asked, do you use Polite Bow or some such to identify your web scraper? If you don't, do the NHS IT people hate you?
No, they don't hate me. Essentially, what it will do is it will look to see if there's an SSL certificate, and essentially, if there isn't, it will still access the website anyway. In terms of the NHS, this has been rubber stamped from the owners of the NHS Data Dictionary, so the website itself. I've got NHS Digital on board who actually run the website. So they're now working with me to enrich this package even further. So yeah, through through me perhaps being a little bit cheeky, creating the package, making it more user-friendly for analysts than they are, it's actually then opened doors for conversations to be had with people that actually run the actual website.
Ramon asks, what's your advice to be involved with the NHSR community and standardize the use of R across different trusts / NHS providers, primary, secondary providers? Sorry, I've said the same thing twice, but.
So if you want to be involved, then that's an easy conversation to be had. I can refer you on as a member. And in terms of the R community and standardization, that's the reason why it was set up. So it was a upskilling platform, but now it's all about how we utilize our best practices, how we can code in R more effectively. And we've also now partnered with our fellow Python program in the NHS. So it's being brought into a more of a collective data science banner. So yeah, there's not just R package funding available now. We also are developing Python packages as well.
Okay, great. Uden asked, if I remember correctly, a website server can inform visitors if web scraping is allowed and how frequently it can occur. Is that taken into account by your web scraping function?
Yeah, it's certainly, like I say, in terms of tokenization and how many tokens you're allowed to ping through. Yeah, that's all captured in the actual web scraping tool. So it uses a few workarounds to avoid that, essentially. So yeah, you can access any website and scrape those components, and you shouldn't receive an error such as that. But yeah, any comments or recommendations, if you want to review the code and make some suggestions, then I'd be happy to look at those.
Okay, great. I think we've come to the end of all the questions. So thank you again, Gary, for presenting. It was a great presentation, and thanks for joining us.
Sorry for the technical difficulties.
That's okay. See you later.
Thanks.
Okay, so I apologize that my camera, I'm looking away and it's kind of awkward. The camera is there, but I can't have the software on that screen because it's too small. And whoever designed my laptop thought it'd be a good idea to put the camera at the bottom of the screen as well. So it's always a really flattering double chin angle. So I'll have to see if I can get a better camera. So I'm actually looking towards you. So last, but by no means least, we have Mango's very own Alejandro Rico. And I will bring you on stage now, Alejandro.
Hello.
Hello.
Hello, you can hear me? Can you see me though?
I can hear and see you.
Okay, amazing.
Okay, I will leave you to it.
Okay, first I'll try to share my screen. As I know how to do that. You should know. Okay, now you should be seeing my screen.
Yeah, but it's just loading. There we go, all good.
Okay, awesome. So, encrypting with R. This presentation, I aim to explain a set of techniques that are widely used in software development, but they are not that known in the R community, just because software development is something that's kind of new on the R universe, because we all come from statistics and maths and whatnot. So I intend to show set of protocols for encrypting passwords, for encrypting conversations, and a set of things and techniques that we can use to set up a blockchain, which is the clickbaity part of this presentation. So yeah, that will be the intention. It's going to be long, it's going to be dense, so apologies for that. I will try to speed up as much so we have the time to cover everything, because it's a lot. But in any way, I will grossly oversimplify lots of stuff, and just because this is targeted for people that may not be experts on encryption and maybe they don't know how a blockchain works and that. So if you are an expert, don't get too mad at me. I need to simplify stuff, just so you know. So who am I? Who's doing this? Well, I'm Alejandro. I'm an R developer for Mango Solutions. I have worked as data scientist for different industries, and video games, and finance, and academia, if you count that as an industry. And, if you want to contact me, Here you have my website, my Twitter, my GitHub. Feel free to check it out. Yeah, but now I just work as an R consultant and Shiny developer for Mango, which is great. So yeah, presentation. So what I am going to talk about, I have explained the objectives, but the different chapters that we'll cover are digesting our objects. What is that? And how we can use that skill to actually protect passwords, how we can use all that knowledge to authenticate messages, which is pretty useful if you are setting up a server with Plumber, let's say. How we can use all that knowledge to actually implement end-to-end encryption, so you can build your own sort of WhatsApp thing with R if you really want it. And then once we know how to do all of this, we can use all those techniques and skills to actually set up a blockchain, which is pretty cool in itself. All of these will be simplified, of course, but I hope it works as an introduction to spark your curiosity so you can actually learn how to do it. So let's get started. First, digesting our objects. We'll be using these two libraries, so you know I'll be using more like dplyr and stuff like that. I think they are widely known and used, so I'm not mentioning them, but these ones are not that known, and they'll be very useful for this. I will be using them interchangeably. You can use either of those or both. They do pretty much the same thing, but as a personal preference, I might be swapping some functions from one to the other. So make sure if you want to replicate this, to have these packages installed. So digesting or hashing. What is that? So digesting essentially means getting a R object, whatever R object, like this array of numbers, and passing it through a function that, using a certain algorithm, pops out a seemingly random soup of characters that don't have any apparent meaning. And that's pretty much it. That's a hashing function. We have different algorithms to do the same thing. Like here we are using the MD5 and it outputs this. Here we're getting the same input, but using a different algorithm, it outputs something different. They're using different techniques, and there are some research on which one is better for what, but they all meet a certain conditions, so you can say that they are proper hashing algorithms. These conditions are namely that they are deterministic. So if I pass the same object many times, I will get the same output every time, which is very important. They are also very chaotic. So if I make a very small change here in the input, even if it's very slight, the output will be extremely different. There's no one-to-one relationship with any change, so it will be chaotically different. And more importantly, there's no way back. So once you've done that, you cannot get this output and infer the original input from this. It's just impossible. Your only hope is to just guess random characters or numbers or whatever until you stumble upon this, which is very unlikely. Actually, we can use it to digest text, for example, and we can see this in action. We have a text, not Penny's boat, whatever that means. If we make a very slight change, like adding a dot here, we can see that the output is just completely different. There's just no way you can tell these ones are similar in any way, which is great. And now we will see how we can use this to something that's actually useful. So, for example, protecting passwords. I'm sure some people here will get started building Shiny applications or some small applications with R, and maybe you have the occasion in which your application requires users to register and then to log in. They need to put in some credentials and you need to verify them. So how do you handle that? How do you protect those passwords, and how these digesting algorithms can help you out with that? Well, first, when I first started developing Shiny apps, my first temptation was to just save those passwords. Someone is typing username and password, and I can just save that in a CSV in my database. Why not? And that's awful. Please don't do that. Never do that. Because you're doing two things that are pretty bad. One is that you can see your user's credentials, which you shouldn't. And even worse, if someone breaks into your database, you have just exposed all the passwords from all of your users and make them public, which is pretty bad. So instead of saving the passwords directly, you should digest those passwords using functions that we just saw, and that's what you're saving. But if we are saving that, we don't know user's password. How we can verify once they log in that they are what they claim to be? So by verifying credentials, if you remember, one of the interesting properties about these algorithms is that they are deterministic. So if you pass 2 times the same password, they will yield the same output. So when a user registers and you save that hash, the hashed version of the password, when they log in and they input the password, if it is the same password, it will yield the exact same output once it's passed through the same algorithm. So you can check that the password was the same that it was used on register without actually knowing the password, which is actually pretty cool. And here it's just an example code on how you can do that. Even if you save the credentials in a CSV, passwords are hashed, remember. And a user is inputting a username and the password, so you digest the password with the same algorithm, and that's what you're checking in your credentials, that the username matches and the hashed password matches with the freshly hashed password. And that's what you're checking. That it starts to feel safe. It's kind of safe. It's not really, really safe because there's an issue with users' credentials is that humans are not very creative when picking up passwords, which means that we use known words, or we use something that has meaning to us, or something that we'll remember, or something that can be guessed. And by that means that potential attackers have huge databases with so many possible passwords that people could be using. So brute forcing their way through the database is not that random of a guess. Instead of trying all sorts of characters, they can just use those databases with possible passwords, which are called dictionaries. And so just saving the password just like that, it's kind of safe, but it's not really safe based on this. So one technique to add a layer of security to this is by salting. It's like sprinkling some salt in the passwords, which is as simple as concatenating some string to the password. For example, with the paste function, we define a salt, which can be any word you want, like bagel, and we paste it just before the password, and that's what we are digesting. And that's what we are saving. So when they log in, we use the same salt, we digest it with the same algorithm, it should yield the same hash, everything's fine, but it's a bit more unique, this password, if you save the database and the salt in different places. A potential attacker would need to break your database and your salt. So it's a layer of security. That's fine. That's great. So now we know how to protect passwords. There are more steps to that in real life scenarios, and maybe you want to iterate this 1,000 times or something like that. So you make attackers' life way more difficult, whereas you are worsening the user's experience from waiting 1 microsecond to 1 millisecond, which it's just the same, but not for a potential attacker that needs to use brute force. So we know passwords. Now, message authentication. So we don't care here for passwords. We care about who's this that's sending me a message. So let's imagine that you are setting up a Plumber server, any application that needs to receive requests, and your server will react according to the requests that it's receiving. But you want to check who's sending me this. Should I listen? Should this server react to what this user is sending me? and you want to check basically the authentication of the ownership of that message. So we can do that, the digesting techniques. So let's see it. Let's say that you send a post request to a given URL where the server is located, and you want to pass a message. Execute order 66, whatever that is. So a simple way to just check that it's me, it's to say, okay, I'll send you a code, a message authentication code, like a secret password between you and I, that only you and I know this word that's special for us. Like when you're trying to enter a secret private club and you knock on the door and they say, password please, and you say, polar bear, I don't know, whatever that is, and they say, okay, correct, you can get in. So same philosophy, same everything. So only those who know that this is the secret code will be able to send a request to this server and server accepting it. So that seems safe enough, but you have an issue that maybe your connection is not really private. Maybe you have connected to a third party that's able to see what you're sending, like maybe your internet provider, maybe you're connected to a VPN, maybe you have connected to something that's called free Wi-Fi airport, I think JD, and now they can see what you're sending. And that's kind of dangerous because they can see the message, okay, we don't really care about that, but they can see the secret code. And that's pretty bad because now they can impersonate you. Now they can send messages to the server and send requests, and the server will believe that they are you. So they can pretend that they are you. And that's not really too safe. So we want to prevent that. How do we do that? By salting this message code. How do we do that? So we develop a hash password function before, if you remember, pasting a salt to the message and then hashing that. If we do that here, we have a message, execute order 66, we paste a salt in it, which is the secret code that we had, and then we digest that, and we have a hash, and that's what we are passing as a secret code. So now the server only needs to run the same function, use the same salt that only you and I know, and they will check that the hash is the same as before. So I know it's you because you are the only one that knows this salt, and we are not sending that salt, so it cannot be intercepted and read, which is already pretty safe, and this should be the way to do it. It has some vulnerabilities that we can discuss, like there's something called length extension attacks that they are using the fact that this salt is just concatenated this simply. And we also have a problem that maybe you didn't realize, but if they see this message and they see the message and they see the hash code, they know that this message relates to this hash code. So they can send this in your behalf, again, many times, pretending to be you, because they know the hash code, even if they don't know the salt. They can just send that. How do we avoid that? Well, there's a protocol that's called HMAC, which essentially means hashed MAC, which, the jest library has a function for it. So it's pretty easy to use. You use a key. That's pretty much the salt that we were using. And same algorithm, the SHA-256. We pass an object, which could be a previous message, could be a number, could be anything. And the technique here is that it's pretty much salting the MAC and hashing it, but instead of just pasting the salt just before the message, it's splitting it and putting it in between. It's doing something complicated, but the philosophy is just kind of that. So that solves the issue of the length extensions attack vulnerability. You can have more information here in a link. But it doesn't solve the issue with the repeated sending of the same message. But there's one easy way to actually fix that. It's just creating a unique ID. So let's say that now my message, instead of just being an action to be taken, it's also an ID that's unique for this message. And that's what we are digesting with the HMAC function. So now we paste the HMAC secret code using our secret key that only you and I know with the HMAC. and we are passing both the action to be taken and the unique ID. So now your server needs to check, okay, is this ID unique, has been used before? If it has been used, don't accept this request. And if it's unique, then digesting this through this functionality here, that's actually pretty simple. Just, is a list of JSON, a JSON character, and that's what we are digesting. And it should yield the same HMAC if you really know the secret key between us. So as long as this key is secret, this is pretty much bulletproof. And this is the actual standard protocol to verifying messages sent to server. So if you want to build a production-ready plumber that's safe, this is the way to do it, pretty much. So now we know how to authenticate messages. So next is end-to-end encryption. Why is that? Because so far we have only cared about authentication of, the sender of the message, but we didn't really care about the confidentiality of the message. A third party could see it, and we don't care as long as they cannot forge a new message by themselves. But what if we care? What if we don't want anyone seeing these messages? That's where end-to-end encryption takes into place. So we need to explain some concepts here. So far, we've been talking about digestion algorithms, which are one way. Information is lost. We take an object, string, numbers, whatever, and we pass it through a function, and it outputs a seemingly random soup of characters, and there's no way back. That's called digestion or hashing. But there's another sort of algorithm that are called encryption algorithms, and that's what encryption is, that they are both ways. They work both ways. So you take an object, you convert it to a soup of characters, and then you have another algorithm to take that back. So how do you do that with R? Actually, you can be pretty naive about it, as I say, and do a kids-like sort of encryption. So you could do something like, okay, A is going to be 1, B is going to be 2, C is going to be 3, and so on. So instead of sending a message, you send something that's encoded in numbers that way. You send that. A third party could just see it and say, okay, this is just a bunch of numbers. And then the receiver can just translate that back to letters, and that would be an encryption. There are some standard ways of doing something like that, like base 64. So we pass a message, not pennies both, whatever that means, as a character. We pass it through this base 64 encoding, and it spits out a seemingly random soup of characters. And now there's just another function as simple as decode, that we take that and we take it back and we recover the original message. So that's great. We have encrypted. And if you don't know what method I'm using to encrypt it, you just cannot tell what was the original message by reading this. But in reality, everyone knows about these methods. So if you're passing this like that, chances are a potential attacker knows this and will try these methods. And they can just decrypt it as easily. It's not really safe. So how can we make it safe? By setting up a key. So there are other algorithms, a bit more complex, that use the same philosophy, but they can only encrypt and decrypt by using a key. So how does that work? So there are functions to create a key, which look a bit messy, but it's just that. We need to transform our message to raw format, which is just a technicality on formatting. And there's a function that's called AES CBC encrypt, and we pass just that, message and key, and it will encrypt the message. And if we try to print it, remember this is raw format, so I need to do these shenanigans to transform it to something that seems like a character. But at the end, this is the encryption, which is, again, a seemingly random soup of characters. It doesn't have any apparent meaning. And there's no way you can decrypt it unless you have that key. Once you have it, you can decrypt it and you recover the original message. So we're safe, we're fine. This feels pretty safe already. Any attacker would need to have access to this key, which, if you have done your homework, is safely stored somewhere any attacker cannot reach, and no one else but whomever has this key should be able to decrypt these messages. So that's great for one-to-one conversations. But let's say that you are developing an app that is expected to be used from thousands of users. How are you going to deal with that key? Are you going to have one key to rule all of those conversations? Which essentially means that you are the key master of it. That doesn't feel very safe, because all those people are having conversations and you can read them all. I wouldn't trust a company that does that and allows that. And even worse, you put yourself in a position in which, let's say, the FBI knocks on your door and says, hey, maybe some of your users are terrorists or political dissidents or whatever excuse they want to make, but we want to read those conversations. And we know you can provide us the key, give us the key. So you cannot say no, I guess. I mean, you technically could, and you can actually read those conversations. So you don't want to be in that position, and it's not really ethical that you do that. So another solution for that is to create a lot of keys, one key for every possible conversation, and the only people that have those keys are the ones involved in the conversations. Seems safe, seems fine. I don't have them, you have them, the users have the keys. But let's think about it just a second. Let's say that you have 3 users, Alice, Bob, and Charlie. If Alice talks to Bob, you need 1 key for that. If Bob talks to Charlie, you need 1 key for that. If Alice talks to Charlie, you need another key for that. Just imagine that with 1,000 users. How many combinations of that can you have? If I'm not mistaken, it's just a factorial of 1,000, which if you try to compute this, it will say infinite. So it pretty much skyrockets with the number of users. So I'm not sure if it's factorial or power of something, but it just escalates non-linearly, which is pretty bad because it makes it unfeasible. So we cannot do that. Do we go for the centralized key master thing that's not really that safe? Well, there's a protocol that was developed in the 70s, I believe. That's called the RSA. That's actually a pretty smart solution that involves what they call a pair of keys. So instead of creating 1 key per user, you create 2 keys per user. It seems more complicated, but it's not, because those keys serve different roles. So you have one that's called a public key to be shared, to be seen. Everyone could see it. And you have a private key. So you as a user have a public key and a private key. Private key is private. It's just for you. Nobody should be able to see it ever. But the public key, you can make it public. Everyone could see it and nothing bad will happen. How is that interesting? Because there's a very smart algorithm. That's a very clever solution. I really like it. That there's an algorithm that picks up 1 key. They are pairs, so they are related somehow, but you cannot infer one from the other, from knowing the other. So it uses the public key to encrypt a message, and that message can only be decrypted with a private key that's associated with that public key, not with a public. If you try to do it with a public, it will just fail. It will throw random characters. It can only be done with a private one. And that's pretty smart, because if Alice wants to have a conversation with Bob, let's say that Bob wants to send a message to Alice, Alice could say, okay, here's my public key, whatever you want to tell me, encrypt it with this key, and then you send me that. And thus, Alice will be the only user capable of decrypting it, because she is the only user that has a private key associated with that public key. So the way it works is that users interchange public keys, so they can send each other messages, and not even the sender should be able to decrypt it. So that's pretty smart, and that's actually how end-to-end encryption works. And you could think, that sounds complicated. It's actually just 4 lines of code in R to do that. There's a function to generate those pairs of keys. You have a key. You, again, format message in raw format. And then there's just a function that picks up the message, picks up the public key that's inside this variable. That's kind of works like a list. So inside the key, you have the private key and the public key. So you pick up the public key, and that outputs an encrypted message. And then again, this is raw format, and I need to do this shenanigans to print it. But if we try to print it, this is it. It doesn't even fit because it's so long of a seemingly random soup of numbers, characters. And then if we want to decrypt it, we need the key, the private key that's inside here. If I try to pass the public key, it will fail. Be my guest and try it. There's no way you can do it. So that's actually pretty safe already. That's pretty much the standard. That's how end-to-end encryption works, and that's how everyone should be doing it. But the key thing here is that where do you store those keys? Ideally, you would store them on the client's device, on the user's device, so they and only they have access to the private key. If you're saving all of those in your general database, you are kind of failing the point of the whole thing. So sometimes a company is saying, we use end-to-end encryption, and you check their GitHub and you see this, and it's okay, it's true. But if they save everything on their database, what's the point? It's just centralized encryption, not end-to-end. So we know now how to encrypt messages. And now, I think I'm missing here something. All of these explanations so you can read it. So now we have learned how to protect passwords, how to authenticate messages, and how to encrypt stuff. And we can use all of that to actually set up a blockchain with R, which is pretty amazing. Should you do it with R? I don't know, but you can do it. And that's what I want to show here. So how do we do that? Let's start by defining what a blockchain really is. So it's pretty much a public database. So it's public, anyone can add entries, and data is organized in small containers of data that we call blocks, and they stack on top of each other, forming what is called an immutable chain. I will explain this step by step. There's a cat here. So this blockchain needs to satisfy a set of properties to make it behave like a blockchain. So whatever these properties, anyone can add entries to a database. That's pretty obvious. Every new entry should be signed by the author, which doesn't seem too obvious, but it's required. Now you will see why. Every entry needs to be verified. So your server handling the blockchain should be able to verify that these conditions are met, and it should require a proof of work. And here I will explain in detail what that means and why that's necessary. So a block, let's define a block with R. Just a list of stuff. The first block of our blockchain has an index, an ID. This is the first block, so 1. It has a timestamp, so when it was generated, and it has a message, the content that we want to actually be deployed in the database. Now it begins. It could be any message. And if we stack them on top of each other, all of us that we like and love R, we can just create a data frame for that. And you see the different blocks that we can create, and they stack on top of each other. They have a growing ID and different messages. And okay, we have a block. It's pretty simple, but it's a block. So now let's go to satisfy all of these properties one by one. So signature. Okay, someone has said, and now it begins, but who's this? Who's sending this? And how do we know that whomever is claiming to send this is the actual user that's doing it? By signatures. So it's just to verify block ownership. And it's a pretty clever solution again, because it's taking the pair of keys that we were using before for end-to-end encryption, and we are inverting how to use them. So before we were taking the public key and encrypting something with a public key and decrypting it with a private key. Now we are doing the opposite. We are encrypting something with a private key Only I can encrypt it that way with that private key. And then I publish the public key, so anyone can check that it was me who encrypted that, because anyone can decrypt it with a public key and recover the original information, even if they cannot encrypt it in the same way. So it's actually pretty clever, and it's pretty amazing. And there's just a couple of functions to do that, so it's not that complicated. So how do we do that? First, again, formatting stuff. These functions are a bit picky with formats. So we have some data. Here you collect data, but it's just this block that we had here. We convert it to a JSON, a character, and then raw. And we have a function, process data, just so we don't need to repeat these lines again. So we get the data, and a function to create the signature would process the data that way. It would need a key, of course, to create the signature with the private key. And there's a function that says signature create. It gets a message. It selects the algorithm that we want to use. It's always this is the standard. It uses the key, and it yields a signature in raw format. So I do this shenanigans again, so it's printable. But just trust me, it doesn't modify anything. It's just encoding in something that can be printed. So now we know this function to create the signature, and we have this function to make it user-friendly. So we should be able to, if someone has signed this, we should be able to verify that that's true. And that's the whole point of it. So here I present a function to do just that. It gets the signature, which remember I encoded it doing some stuff, just in base 64 and splitting it in commas and listing it, because this function is kind of annoying with that. And then in raw format again. And we get that, we get the process data, we get the same algorithm, we get the public key this time, and there's a function to verify the signature, just like that. And this will output a true or false based on if this is checking that this signature was generated using this data with the private key associated with this public key. It's just doing that. So we know if we see a signature from somebody that claims to be using this public key, this key, we can use this function and verify that that's true. And we can actually see that in action. So we get ourselves a pair of keys with this function. It's pretty handy. We generate some small block of data. So again, an index, a timestamp, a message, and the previous signature, because it's the first block, so the previous was nothing, so it's empty. And we use the function that we just created to make a signature, and we just paste it as a character in the data block. That's it. And now if we print it, we see that's, huge string of characters. And now we can verify it. So if we get the data, everything but, the signature, because we don't want to violate causality. This was generated without this. And we get the signature and the public key. And again, we are checking that this signature was generated using this data by the private key associated with this public key. And it gets us a true. So we know it's true. We did it. It should yield a true. But we can check it without having to trust anybody. This is the main idea behind this. So we know how to sign and we know how to verify signatures. So that's fine. Now let's go to proof of work. So what is the idea behind proof of work? If we make a public database and we allow everyone to send anything, it will probably be swamped with random silly requests and messages almost immediately. So one easy way to avoid that is to make it non-free. And non-free means that I could be charging a fee, but if I'm not that greedy, I can just make people prove that they have spent some computational time doing something silly and pointless, but so I know that it's not free for them because they are spending sweet, precious computational time on doing it. That's how Bitcoin does it, by the way. They use a different function for proof of work, but the idea is the same. So a silly example that I provide here is to finding prime numbers. So if you want to add anything to our blockchain, you need to give me a new prime number. So here you have a function that looks for a new prime number. So it just iterates numbers until one of them is prime. So that's not very, that takes time. Maybe not for the first 1,000 numbers, but then it will start to get slow. And we have a very easy and simple and quick function to just verify that that's true. So we have a proof of work defined. That's easy. And now we have everything necessary to actually create a very real block 0, which is the first block of a blockchain, right? How do we create it? Being realistic. So we need, again, an index to have a unique identifier. Remember the HMAC chapter before, why we need this? This is necessary. A timestamp for similar reasons. A message, the actual data that we want to deploy. This is the useful stuff. We provide the old proof of work, which is a block 0, so it doesn't make really sense, but I'll just give here the first prime number, because I'm not sure if 1 is a prime number for all those mathematicians out there. Please check that. And I provide the next one, which is 3. And the previous signature, of course, it's empty. So I have created a block 0, and now I pretend to send it to the blockchain. And now the blockchain needs to verify, okay, who's sending this? So I need to sign it first. So we've learned how to create signatures. So here's a handy function to do it. So we get ourselves the key that we created before. And we actually make the public key part of the block. So our public key will be public. And we use that, all that new block, that's all of this, plus the public key, to hash all of these together using an algorithm that takes our private key and creates a seemingly random soup of characters with no apparent meaning. And we add that as our signature, which is the new signature for the block. And we return that. So in action, this would look like, okay, we get ourselves a key. We have this block. So now we sign it. And we can see that as a data frame. It doesn't fit in the screen, but now you'll see one. And so that's great. Now we have our first block of our blockchain. And now we can actually make a chain of these blocks and stack all of them together. How would that look? Actually, you can make it as easy as, okay, we have the block 0. We call that a blockchain. We get ourselves a pair of keys, and you get, okay, blockchain, add block, add block. This function I just created here, it gets a blockchain, a message that you want to add to the blockchain, and your key, of course. Otherwise, how can you sign it? So this function would take the last element of the blockchain, which is the last block, of course, and it would say, okay, our new block needs an index that's increasing from the last one, so +1, a new timestamp, of course, the message that we are passing every time. I mean, now we probably want to pass a new message, so new message. We need to specify which one was the old proof of work. So it was just the proof of work of the last block. And then we use that to find ourselves the next prime number. It's the new proof of work. And we fill the previous signature by using the old new signature. And it sounds a bit confusing, but I guess I hope it makes sense. And we sign that block, so we have learned how to do it. And we stack it, as a data frame with our bind function. Everything is very R friendly. It's just a data frame. And it's a add block function that we can pipe together, because we all love to pipe things in R. All of us, those who use the tidyverse at least. So we can get the blockchain and add a block that has a message, and it's using this key. And just like that, we have added a new block to the blockchain. Super simple. So now dark wings, dark words, no, now it ends. Messages for them, blockchain. And if we see that, we can check how that looks like. And if we were to check that database, let's just see the last example that we have built. Just example, you could see all of it, but it wouldn't fit in the screen. So we see that it has an index that's the third block. The last one is the third block. a timestamp, the message that we are sending, which one was the old proof of work, which one is the proof of work of this block, the signature of the previous block, the public key of whomever has created this block. So this is the ID that identifies the user that has created this block. And this is the signature that it has created. So now we should be able to check this public key and use it to decrypt this. And it should create all of this. It should give us back all of this. Decrypting this hash with this key should give us this block of data. So we should verify that. How do we verify that? Because here we have just created very naively all the blocks all together. But if you're deploying a blockchain and you're maintaining it, your server should verify those blocks before actually adding them, because maybe they are wrong or they are, malicious or something. So how do we verify it? We have actually created all the functions to do that. We just need to make it pretty and make it tight and make it useful. So we need to check actually all these properties, which are, is the proof of work that you have provided actually a prime number? Because you can just type whatever number, right? So we need to check that that's true. Okay. We need to check that this proof of work is actually higher than the previous one. Otherwise, you're just repeating the same known prime numbers, right? We need to check that, and we need to verify the signature. Otherwise, you might be lying with your public key or your signature or whatever. So we need to verify the owner of the block. And all of this needs to yield true. Otherwise, the block is rejected and it's not added to the blockchain. So if all of these say true, the block is added. And that's it. That's how a blockchain works. So how is this useful and why is everyone talking about this? Because here, this message, now we have been using silly messages as examples, like quotes from something, but you could actually deploy pretty useful information. And the most obvious example for this is how Bitcoin does it. It provides a message that's basically saying, okay, Alice sent this many dollars to Bob. And then another message that says, okay, Bob sent this many dollars to Charlie. And so, and on and on. And those then you can use this public database as a public ledger to know who's got what money. And then if you remove the abstraction of saying dollars, you can say Bitcoins as an imaginary token that we all share using this. You got yourself a cryptocurrency. That's pretty much it. So the only caveat here that you would need to provide signatures for the sender and the receiver or something like that. So it's slightly more complicated, but we're just adding here a couple of columns. Same process, same everything, same philosophy. It's just so you add layers of usefulness to your blockchain. So it's actually useful for something. And here we just created the most basic skeleton of what a blockchain should behave like. But you can make any tweak here so it can actually be used for something. The blockchain of Ethereum uses this to sign contracts, for example, what they are called smart contracts. So just be creative, get this and do something that's actually useful, and you could get filthy rich if you do it well. So that's it.
Thank you very much. Okay, we have some questions.
Okay, let's see them.
The first one from Udon says, I like your presentation layout. What did you use to create it?
Thank you. That moves me. I've spent much more time on the looks of the presentation than the content, unfortunately. So I'm using Sharingan. Google it. It's a library. It's pretty useful for presentations. It's just like that. It's using R Markdown with some complicated stuff that I don't really understand, but yeah, Sharingan.
Ryan asked, does this mean we could use R for crypto tidy coin incoming?
I hope so. Yeah, you could. I mean, you really could. Should you? That's another question, but you actually can do it. I was thinking of an R coin, but yeah, tidy coin sounds all right.
Lots of comments, people saying that they really enjoyed your talk.
Nice.
Really nice. Mr. Rico enjoyed it a lot. That was amazing, Alejandro. Thank you. From Caroline. We'll give it a few seconds, see if we get any more questions in. Udin says, thanks for my first blockchain training and for looking at your concise coding style. So thanks for the inspiration.
Thank you.
Very nice.
It was a bit dense, wasn't it?
I understood all of it. It's actually very basic to me.
Okay.
No, I'm lying a lot. I think that is it questions wise. So I will draw LondonR to a close. I'd just like to say thank you to Robert, Gary and Alejandro for giving up their time presenting to us. It's really appreciated. And thank you all for joining us this evening. You'll probably get an email in an hour just asking for your feedback on using this new system. It's just asking you to rate it from 1 to 5. But if you have any other sort of thoughts or feedback, please drop me an email. I really appreciate to hear what you all have to say. Just events@mango-solutions.com or just tweet me at @mangothecat. And if you enjoyed today's session, please drop us a tweet. Like I said, #LondonR @mangothecat. But yeah, thank you very much, everybody. And I'll send out the recording hopefully tomorrow, if not sooner. All right. Cheers. Bye all.
Cheers. Bye-bye.